Hey everyone, today in this video we will talk about the problem statement MK average. This is one of the problem statement which is asked in the Google interview, and this is a Leetcode hard problem. Now we'll begin with the problem statement. So it says you are given two integers m and k and a stream of integers. It means initially the two integers are given m and k, and then there will be a continuous stream of integers. It means one by one integers will keep on coming. You are tasked to implement a data structure that calculates the MK average. Okay, for the stream. The MK average can be calculated using these steps. If the number of elements in the stream is less than m, you should consider the MK average to be -1. Otherwise, copy the last elements of the stream to a separate container. Got it. So at every point of time, we need to maintain the last m elements. That's one thing which we can understand from the first point. Remove the smallest k element and the largest k elements from the container. Okay, so the last m elements should be sorted, and we have to remove the first smallest k elements and the largest k elements. So the remaining we have is m minus 2k elements. Calculate the average value for the rest of the elements rounded to the nearest integer. Okay, so average value, so basically sum of the remaining m minus 2k elements divided by m minus 2k. That will be our answer to the calculate MK average function. Now let's go through this sample input. So initially we have 3, 1. So m is equals to 3 and k equals to 1. Next we have add element operation. So it's adding 3. So in our stream we have 3 as a first element. Next add element and the number is 1. So we'll add 1. The next is calculate MK average, but then currently the stream only gave 2 numbers and our m value is 3. So the current numbers are less than the m value, so it will be -1. That's how the output is -1. Got it. The next is add element, and the element which is getting added is 10. So 10 will be added here. The next is calculate MK average. Okay, so we now have 3 numbers. So let's, if we sort this 1, 3 and 10, and if we remove the smallest k, basically the 1 and 10 will be removed, so 3 will be there, and the average is 3 divided by m minus 3. So I'll just write it, m minus 2k is equals to 1 for this problem, for this example. So 3 by 1 is 3, so our output is also 3. The next is add element, and the element is 5. So the element added to the stream is 5. The next is, okay, the other two operations are also add element and number are 5. So it will be 5 and 5. And then it calculates the MK average. So the last m elements are these 5, 5 and 5. So the average is 5 only of these three elements. Now let's suppose in this example the MK average was called at this point. So the last 3 elements were 1, 10 and 5, and the sorted order will be 1, 5 and 10. So the output will be 5 for this average. And if the MK average is called at this point, then the last 3 elements were 10, 5 and 5. Sorted order is 5, 5, 10, and their output will be 5. So okay, this is the problem statement. Now we are able to understand the problem statement. Now let's see what all data we need to store. So first couple of points is that we need to store the last m elements. Okay, we need to store them last elements in the sorted order. Then next is we have to maintain the numbers sum of m minus 2k numbers, basically from this m elements, and then return the average whenever the average function is called. Also we need to maintain a list of the incoming stream and remove and have the last m elements. So for this, what I am thinking is that we can have multiple data structures. So basically the first data structure is a list, a linked list to store the stream of events. The second data structure is a priority queue, and third is a tree map. Now I'll tell you how. So the approach that we'll be taking is that we will create 3 separate buckets. This will contain the smallest key elements, this will contain the largest key elements, and this will have the mid elements. Okay, now every time a new number gets added, it will be checked that this new number n, lies in which bucket, either mid, smaller, or greater. So this number will be added. Suppose this number get added to the mid one, so mid will have this number n. Now there are conditions that the mid bucket will have maximum size of m minus 2k, and these two first and third bucket is maximum size will be k. Okay, so after adding the number to any of the bucket, if the size of the bucket does not satisfy these conditions, then it has to rebalance. How it will rebalance? That first is if mid has more number than m minus 2k, so it will remove one element. It will either remove the largest element to go to this larger bucket, or remove a smaller element to go to the smaller bucket, depending upon which bucket has capacity. Okay, now if all these 3 buckets are already full, and the total sum is greater than m, then we need to remove the last number basically in the list. For example, the same example that we took. So in this one we have 3, 1, 10 and 5. 3, 1, 10, 5. So in this one, so initially the buckets were, so 1 was here, 3 was here, and 10 is here. Now 5 is added. Now 5 will be added to the mid bucket, right? Now mid bucket has size greater than its capacity, but if you see, the overall capacity of the list also is increased. It is greater than m now, so we have to remove one number. Which one it will be removed? The oldest one, 3 will be removed, because we have to take the latest m numbers. So 3 will be removed, and that's how 3 will be removed. So 3 will be removed from the mid, so it will be 1, 5 and 10, and that's how the balancing will work. So let's suppose if 1 was removed from here, now in the next iteration 5 comes, now the 5 will definitely go into the mid bucket. Now 1 will be removed, so this smaller bucket is empty, while mid bucket has 2 numbers. Okay, so in the rebalancing, from mid 5 will go to the smaller one, and the newer bucket will be this. That's how the logic will work. Now to store the numbers in the buckets, the data structure that we are using, so for the mid one we'll use a tree map. For the smallest and the largest k buckets we'll use a priority queue, and to maintain the order of the list, basically the stream of numbers, we'll use a linked list. So this is a complex problem statement. If you have not understand it perfectly, please rewind the video and watch it again. I'll move on to the coding part now, and after explaining the code I'll discuss the time complexity and space complexity. So space complexity is not that difficult. I assume you all may have already guessed it. So it will be O of m, as we are storing the m elements at a time. Okay, so here's the code for the problem statement. We have defined the 2 priority queues for storing the smaller and the largest k numbers. We have defined a tree map to store the mid range, a linked list to store the stream of numbers, m and k to store the initializing inputs, and midsum and midsize for calculating the mk average. And the priority queue that we are having is, the larger priority queue is a min heap, so that we can get the minimum of the numbers from that largest k numbers, and the smaller will be the max heap, so that we can get the largest of the smaller k numbers. So whenever there is an add element operation, so it will be added to the linked list first, right? And based on the sorted order where the number lies, this will be added either into the mid or smaller k numbers or the larger k numbers. And after that, when the number is added, it will check if the total numbers present in the current stream is greater than m or not. If they are greater than m, so the last number, so basically the first number which was added to the string, will be taken out. And once that number will be taken out, it has to be removed from one of these three buckets, wherever this number lies. Now after this, the numbers are removed, we have to rebalance the three buckets. So this is the remove function. It just checks where the number is currently present and it removes from there. This function inserts the number into the mid at the sorted position. Decrease mid, this is just a function to remove the number from the middle tree map, and similarly remove the sum from the mid sum and decrease the mid size. Now this is the function rebalance, which we discussed earlier, that whenever any one of the buckets exceeds the capacity limit, then the bucket needs to be rebalanced. So first is, if any of the buckets, it says if the smaller size is greater than k, large size is greater than k, or mid is greater than m minus 2k, then this loop will keep on running. So if my small bucket is greater than k, so it means I'll have to remove the element from small and insert it into the mid. Okay. If my mid bucket is exceeding the capacity, now there are two conditions. Either from mid the number can go to the smaller bucket, or from the mid the number can go to the larger bucket. It will depend which bucket has the capacity. So if my small bucket has the capacity, so the smallest number from the mid will be removed and will be added to the smaller bucket. If the larger bucket has a capacity, then the largest number from the mid elements will be removed and it will be added to the largest k numbers. And if my largest k numbers bucket exceeds the capacity, then the number will be removed from that bucket and will be inserted into the mid bucket. And that's how the rebalancing will work. And so that's how the add element function will work. Now in the add element, we are always updating the mid sum and the mid size. So during the calculate average, this will just calculate the current sum divided by the m minus 2k and return the value. So the calculate mk average function will take O of 1 as the time complexity. While add element, now in the add element, the maximum time taking part is the rebalance operation. So you can actually evaluate yourself. So this insert operation, this is inserting into the tree map. So the maximum it will take is log of m minus 2k, because that's the size of the tree. The priority queues will take log of k. Right, the remove will again, it will take the maximum as log of m minus 2k. But the rebalance, so think of it as from the smallest bucket, let's suppose we're having the size of k, all the elements move to the mid tree, and that's how inserting an element to a tree map takes log of m, as although it will take log of m minus 2k, but since m is very greater than k, so it will take a log of m, and there will be total k number, so it will take k of log m. So that was about this problem statement. I hope you like the video. If you do like, please like the video and subscribe to the channel. Going forward, I'll make more such videos on the different problem statements. Thank you.